Hi everybody, here's tutorial 2, part 1. This tutorial is going to be in multiple parts as well, and this first part is going to be a review of the new material that was added during the in-class project last week. So arguments to jit.gl.gridshape, messages to jit.gl.gridshape, messages to jit.anim.drive, and the new jit.gl.camera object. I won't necessarily do a review tutorial every week for material that's presented as part of the in-class project, but since you're just getting familiar with this environment and since you're not necessarily in a self-learning modality with it yet, I thought it would be valuable for you to have this review information, but I'm going to go through it fairly quickly. So I've created a new patcher. I have segmented patch chords on, auto fix width off. I'm in Monaco, a fixed width font at a slightly larger font size, and I'm going to create a jit.world, name it, and again, anything that's in all caps means you can name it arbitrarily. You can give it any name that you want. I would recommend when you do that to keep yours in all caps as well to remind you that this is an arbitrary name. And I recommend the @floating one attribute so that your world floats on top and doesn't fall behind other things. Of course, we need the T for toggle, which allows us to turn on our world, and we can tell it's on when it goes to a gray background. We'll be able to change that background color later, but for now we'll leave it. And we worked with the jit.gl.gridshape object, which by default creates a sphere, and we'll go through the various attributes of jit.gl.gridshape that we discussed. First of all, we talked about lighting, enable, turns on lighting, which allows us to see that it is in fact a sphere. Smooth shading, which causes the renderer to shade across the faces, giving us a smooth appearance. I'm going to turn that off for the moment, and note that 1 is on and 0 is off. This is binary, ones and zeros, Boolean. We call it also true and false. So lighting enable is true or on because of the 1. Smooth shading is off or disabled because of the 0. We looked at color with redness, greenness, and blueness as the 3 values. And I'm putting a space between each one of these. We looked at scale, where the width, height, and depth of the object are specified as floating point values. And of course, these don't all need to be the same. So the width of the object could be quite large. We looked at position, where the position is in X, meaning right to left, Y, meaning up and down, and Z, which is backwards and forwards. So, for instance, if I position this sphere right in the center, I can make another sphere of a different color. And I can position it 1 meter to the right, or ½ a meter to the right, or I could position it directly in the same position as the other sphere, and then I could move it back and forth in space. I could move it away from the camera, say 2 meters back, and now it's there, but it's behind the purple sphere. So again, if I made it larger, I've got my teal sphere, scale 111, so quite large, behind, 2 meters behind the purple sphere, which is quite small, 0.2 meters, positioned at the center of the screen. Always you want to save your work as you go. and save often, because if the computer crashes and you haven't saved, you lose all your work, and that's unfortunate. We can look at rotate XYZ, which actually with a sphere is not going to be very visible. So let's look first at shape, where we can do different shapes such as a cube, or a torus, and some of you mentioned to me that you don't mind reading all the information across in a complex line, but just take a look at how much more readable it is when you take a moment to sort of adjust the width of the object so that everything, all the @ signs lined up, and you can really read what it is that's in your object. So shape, cube, shape, torus, and then if we rotate, and we want to rotate XYZ, there's multiple ways to rotate three-dimensional objects. Rotate XYZ is the easiest to think about because it rotates on the 3 dimensions that we know of. So if we rotate 30 degrees on the x-axis, we imagine the x-axis running horizontally through the object like a skewer. It's going to have the expected effect, which is to rotate it along that x-axis. Similarly, if we rotate it 30 degrees on the y-axis, which is the vertical one, we'll see a further rotation of the object along expected dimensions. Now, there are other useful ways to rotate objects. So we've got that. With our torus, we have a special attribute called rad minor, which is the size of the hole in the torus. So a rad minor of 0.9 is a very small hole in the middle. A rad minor of 0.1 is a very large hole in the middle. And also we talked about dim. So dim 110, for instance, it's very easy to see the effect of dim when we're working with the torus. So the dim 100 is the smoothness of the individual tube segments, and the dim of 10 is the number of segments that are used to make up the torus. So if I did this the other way around, 10 100, I see a very smooth circle that's broken up coarsely. And if we add some rotation to this, I'll rotate it 45 degrees on the y-axis, the vertical axis. We can see how smoothly it's functioning in one dimension and how coarsely it's functioning in the other dimension. So that's dim. And then we talked about this quite a bit in class. We looked at the poly mode, which is how the object is drawn. So poly mode, poly mode 0, 0 is our ordinary drawing mode, which draws solid faces. Poly mode 1, 1 draws a wireframe of our object. And poly mode 2, 2 draws dots at every vertex of the object. And you can combine these. The first one is about the side that's facing us, and the second one is about the side in the back. So for instance, poly mode 1, 0 is going to draw a mesh for the front-facing side, but fully render the back-facing side. So you can see this mesh here. We're seeing through the sides that are closest to us, and we're seeing solid sides at the back. Or for instance, poly mode 1, 2 is going to draw a wireframe mesh for the sides facing us and just dots for the back faces. So these are interesting things to play with and use. And let's see, what else was there? Dim, shape, rad minor, poly mode, position, rotate, XYZ, scale, color, RGB. Okay, so that's enough for these objects. I'm going to put this back in poly mode. That's enough for the jit.gl.gridshape object. And the next thing that was discussed is that any of these attributes can also be a message. And any and any argument to a message can be replaced with the changeable argument $1. So for instance, if I want to rotate my cube smoothly, I can set a message, rotate XYZ. And if I want to rotate it on the y-axis, I just make the second value, the y value, changeable. And then I can hook this up to a floating point number box and actually enter the rotation that I want. And similarly, I can do this with scale. Where I'll assign $1 to the x component and 0.2 to the y and z, and now I can change the scale of my object along the x-axis. And of course I can assign it to two values as well. So I could, for instance, scale, leave the x alone, and scale y and z simultaneously. So x is always fixed at 0.2, but y and z are varying with the input from the floating point number box. And we looked at this, we haven't talked about it specifically in a tutorial yet, but number boxes are not just for viewing values, they are also for entering values. And write any message by removing the at. So if we want to change the shape, we can simply say shape cone, and when we send that to the object, when we send that message by clicking it, the object then becomes a cone. And the last thing that was in the in-class assignment was the jit.gl.camera. So I'm going to just take some objects that I created elsewhere and paste them in. Here I have a yellow sphere that is 1.5 meters above the center of the world, and I have a red cube that's 1.5 meters below the center of the world. And then also the jit.anim.drive connected to our new object, which is the jit.gl.camera. Now jit.gl.camera is not creating a camera because there's already a camera. This is the camera's view. But it's creating a control for the camera in our world. And one thing, just a little trick that I used with a few of you, but I'll just show it to everybody. Since I have two shapes and they're stacked vertically, I want the orientation of the objects on my screen to be stacked vertically also, just to be helpful to me. They don't have to be, they could be like this, but it's useful to me to recognize this is the top object, this is the bottom object. Also, when I click an object, I can change its color, and I can change everything about it, font size, but I can change its color quickly here and mark it with a color so that I have a little visual guide that this is my yellow object and this is my red object. Now obviously if I change the colors of the object in my patch, this will be wrong, but for the moment this is a simple way to help keep track of objects. So we can see I've made my objects and they're not fully in my camera view, so I can back my camera up. Think about using a camera in a real world situation. As you move the camera away from the objects will appear smaller and more space will be in your screen. So I can use the move to message, except rather than moving the objects, I'm going to move the camera. So I'm going to move to, say, 10 meters away. And the default camera location is 2 meters away, so I'm going to be moving 8 meters back, and then move to requires a time. Let's do this over 5 seconds. So I'm going to move to 0, 10 over 5 seconds. Watch what happens. The camera is going to back up 8 meters, and now I can see both of my objects. Great. And I can also move my camera to the left by 5 meters. So I'm going to move it to -5, 0, 10 over 5 seconds. So my camera, imagine my camera being on a set of tracks. I'm going to truck my camera to the left by 5 meters over 5 seconds. And there it goes. But note that the camera is no longer pointing at the objects. The objects are moving out of frame, which is fine. This is like pointing a camera out of a car window as the buildings go by. You're going to see them pass, and we can illustrate this by taking our objects and making some more objects. Put these 1 meter, 2 meters to the left of the other objects, and I'll put these another 2 meters to the left. And put them even further apart. I'll put these 3 meters to the left. I'll put these 6 meters to the left. And so now, as my camera goes past them, we can see my camera is facing the same direction and the objects are passing through the frame. There's another way in which we can use the camera, though, which is to have the camera look at a specific object and lock its look at to that. So I can take this first sphere here. I'm going to change its color so it's more apparent which one I'm talking about. I'll make this one blue-green. Oh, that's just blue. Make it blue-green. And it's at position 0, 1.50. So I can tell my jit.gl.camera where to look. I can say look at 0, 1.50. And now my camera is going to look at that location. But the problem is the camera is now looking at that location and it doesn't update its look at unless I say lock look. And now, as I move my camera away from the object, it remains locked on looking at that object. Regardless of where I move my camera, it's always looking at the teal sphere. So that's look at with lock look turned on. Also related to this is the tripod attribute. Because if we take a look at this, we've got our look at is set to the location of the teal sphere, our lock look is 1, but let's try and move the camera to the other side. Let's move it 10 meters behind the teal sphere and see what happens. I'm going to move it to -5, 0, -10, so it's going to pass behind the sphere. And whoa, wait a second, everything's on its side, because the rotational calculations the camera is doing is not respecting the fact that we don't want it to flip around. We may want it to flip around. This is an interesting thing, but if we don't want the axis, the horizon, to shift, we need to put the camera on a tripod. And now this looks the same, but then if we were to move the camera around behind the sphere, our horizon remains consistent because we've placed the camera onto a virtual tripod. And the final thing that we want to look at is the lens angle, which defaults to 45 degrees, but if we want to virtually change the type of lens that's on our camera, we can do that. This is our 45 degree lens, that's ordinary. If we make this a 90 degree lens, we get a much wider angle. If we make this a 24 degree lens, we're much closer, and you can see how changing the lens angle, or the type of lens it's on the camera. It changes the field of view. And that's all for the review of material that was in the in-class projects. And now in the next part of this week's tutorial, we're going to look at some new material, which should be super interesting. So stay tuned.